What's up everybody, welcome to another video. Hope you're ready to flex those brain muscles. In this video we're going to continue factoring quadratics, this time using something called the AC method. So in my last video we talked about trial and error, which is essentially looking at a quadratic like this and thinking about what could its factored form look like and writing stuff out. 8x and x, 4x and 2x, and then using sort of what we know about quadratics to figure out what its factored form is through trial and error. And that's a great method. I'll link the video above. I really like it. But what the AC method allows is a method that where there's no guessing and checking, right? We can just get to the factored form. In some cases it's a little bit of work, but again, it's one of those methods that it just always works as long as you do it properly. So how does this AC method work? Well, the first thing we're going to do is look at A and look at C. That's why it's called the AC method. A is 8, C is 3. Remember, we have the form ax squared plus bx plus c. So a is 8, c is always that constant term. We want to multiply these together, right? 8 times 3 equals 24. And why we care about this 24 is we use this 24 to find two numbers that multiply together to be 24 and add together to be 11, right? So we're always looking at b, right? We want two numbers that multiply together to be a times c and add together to be b, which in this case is 11. So let's list them out. And again, since 11 is positive, we only need to consider the positive factors. Negative factors will add up to be a negative number, right? So 3 and 8 it looks like is going to work. So we can take 3 and 8. These are our magic numbers. Why do we call them magic numbers? Well, look what they allow us to do. Is they allow us to expand this x term, this 11x. We can expand it out to plus 8x plus 3x. Hopefully you agree that plus 11x is the same as plus 8x plus 3x. Now we have this plus 3 at the end chilling. So this expression here with 1, 2, 3, 4 terms is the same as this quadratic I was originally given. So we're good. It's the exact same thing. And now we're going to factor by grouping. So we're going to look at the first two terms, the last two terms, and take a common factor out from each. So between the first two terms, what do we have in common? We have an 8x, and what I have left when I factor out 8x is just x plus 1. And from the second two terms, they share a 3 in common. So I can factor out a 3, and what I have left is x plus 1. And if you do this correctly, we should always have the same thing in each of these sets of parentheses, because that's what allows us to do our next step, which is factor out this x plus 1. So really what we're doing now is called factoring by grouping. So if you're unfamiliar with this, this may look very weird. If you are, then it's probably not that weird. But if you are unfamiliar, I'll link a video. I'll pop it up above. Factor by grouping. So we can think of this x plus 1 being a thing that we're taking out, a common factor between both of these terms, right? For example, if this is a term and this is a term, then they share a factor of x plus 1 in common, and we could take that out to the front, right? So that x plus 1 can come out front. And what we have left is, well, an 8x in the first term and a 3 in the second term. And this turns out to be the factored form of 8x squared plus 11x plus 3, right? So if we can multiply a by c, find two numbers that multiply together to give us ac, but add together to give us b, and then expand out the quadratic, use factor by grouping, right? So that's essentially the process. That's what we're going to do each time. But first, before we get into more examples, I want to talk about why does this method work, right? Because to me, it's not obvious that there's some connection between a times c and b, right? Numbers that multiply together to be a times c, add together to be b. That's a little weird. It's not obvious. So if you are interested, I'll show why this works. And we can kind of figure it out ourselves by just considering two, arbitrary binomials. So this is the form of any binomial. We have like, coefficient x plus some constant. So I'm just using the letters a, b, c, and d to represent these numbers. And when we multiply two binomials out, what happens? Well, we get a times c x squared, right? So that's our first. Then we have our outer, that's a dx. Then we have our inner, that's b cx. Our last, that's the product of the two constant terms. And again, these are rules we were using for trial and error. We can see them clearly, which is that like, hey, we always get our x squared term from the product of the two x terms. or that we always get our constant term from the product of the two constant terms, right? So let's combine like terms here, because that's what we can do. Even though it's a little bit weird, we can combine like terms. And so what we're left with is AC x squared plus, well, when we combine like terms, we add the coefficients, AD plus BC x, and then finally left with plus BD at the end. So this is as simplified as combined as it can get. So let's consider what AC is. AC is the product of this coefficient here, the coefficient of the x squared term, and the constant term, right? So if we think back to our AC method, I know I'm using A and C in a different way here, which may have been confusing now that I think about it, but hopefully y'all can follow. We multiply these two things together using our AC method. This is what we do. And look, multiplication, we can use commutative, associative properties, right? We can rewrite this as A times D times B times C, right? These are definitely equal. I just switched up the order, but everything's being multiplied, so it's all good, right? So this together is A times C, right? X squared coefficient times constant term. And look, each of these are a number. This is some number, this is some number. They multiply together to be A times C, and look, they add together to be the coefficient of our X term, right? Our B. So hopefully you can visually see, oh, okay, I kind of see the connection here and get some idea of why this method works. All right, let's get into the next example. So again, the first thing we do is A times C. So 12 times 5 is 60, and now we're looking for two numbers that multiply together to be 60, but add together to be 19. So again, since it's positive 19, we can just consider the positive factors here, 1 and 60, 2 and 30, 3 and 20, okay, 4 and 15, that's what's going to work, 4 and 15. So those are our magic numbers in this case. And so now we can say as well, we can rewrite this and we can just expand out the 19x, right? So a question I get a lot is, how do we know whether to put plus 4x plus 15x or plus 15x plus 4x? The answer is it doesn't matter. Either way you do it, it'll work. Okay, so let's try both in this example, and then I'm never going to do both again. I'm just going to pick one from here on out, but I do want to do both just to kind of show, hey, they both work. So first I'll try the plus 15x plus 4x. So common factor between the first two terms is what? A 3 and an x. That's what I'm seeing, a 3 and an x. And what I have left is 4x plus 5. Here, what's a common factor? Well, they don't really share anything in common, so we just say that the greatest common factor is 1, right? And so we can think of there being a little invisible 1 there, but what we see is that we get exactly what we want, which is the same thing in both parentheses, right? 4x plus 5, 4x plus 5, and so that's what we want to factor out, and that's why I think it is helpful to put this invisible 1 here, right? Because it helps us see what we're going to have left when we take 4x plus 5 out to the front in both of these terms. What we have in the first term is 3x, and what we have in the second term is 1, right? Hopefully you can see that. And again, if we treat this as one single thing, instead of foiling this out, if we treat this as one single thing and distribute, we get back to where we were. All right, again, I said I would do this, but this is the only time I'll do this, and let's do it the other way. 12x squared plus 4x plus 15x. So again, what if you wrote it out this way? Would it still work? Well, let's find out. Let's take the greatest common factor. Now what's the greatest common factor? 4x. What do we have left? 3x plus 1. That 3x plus 1 is looking familiar. Here we can take out a 5, and what do we have left? 3x plus 1. So you hopefully see how it's going to work out. I see my 4x plus 5 here, and I see my 3x plus 1 here. And so when I take the 3x plus 1 out in front, I'm going to have 4x plus 5 left over. So either way you do it, it works out. And I don't even really think one way was easier than the other in this case. And in general, I don't really think it is. I think it's about the same. Awesome. Let's try the next example. Let's mix it up with this plus or minus stuff. So this time we have a positive 9 and a negative b term. Let's see how that changes it. So again, AC method. A times C is 4 times 9, that is 36, factors of 36. So this time, what do I need to be careful of? Well, b is negative, negative 15. So I want numbers that multiply together to be 36, but add together to be negative 15, okay? Which means that both numbers have to be negative, right? That's the only way for two numbers to multiply to be a positive number and add to be a negative number is if they're both negative. So now I'm going to consider the negative factor pairs, like negative 1 times negative 36, negative 2 times negative 18, negative 3 times negative 12. Oh, that's going to work. That's going to work. All right, so let's try it. Let's write this out. 4x squared minus, so again, I'm just going to kind of do it however I want, minus 12x minus 3x. Let's do it that way. Plus 9. All right, so factor by grouping. Common factor, first two terms. Looks like 4x to me, right? Both share a 4, both share an x. What do I have left? X minus, what is that, 3? Awesome. What about these next two terms? Well, let's see. They both share a common factor of 3, and I think that's the greatest common factor. So I can take out a 3. Here's where we need to be careful, is that if I write minus 3 here, and I put a parentheses here, we got to be real careful, right? When I distribute this back out, this negative comes along with the 3. So this is in fact x, right? But I need to actually change this to minus 3, which makes sense because I had x minus 3 in this first set of parentheses, right? And like I said, if we do this right, then we should get the same thing in each. But hopefully it makes sense why, because remember, when I distribute, if I want to go back to this step, I do negative 3 times x, that gives me negative 3x, and then I do negative 3 times negative 3, that gives me the positive 9. So when you're taking out a negative here, we need to be really, really careful and just double check our work there. So again, now we're taking out the x minus 3 out front, and what we're left with is 4x minus 3. Awesome. Hopefully that makes sense. A little bit tricky there, but we just got to double check our work and think about it carefully. All right, a times c, what is that? AC, let's see, 8 times negative 3 is negative 24. I'm going to include the negative, right? Because I really want to be mindful about these signs. It really matters. Because now what I'm saying is I need two numbers that multiply together to be negative 24, but add together to be 2, right? So that means one has to be positive, one has to be negative. And hopefully you can go through in your mind and kind of see like how some of these obviously won't work. Like we probably don't even need to write these down, right? No, not going to work, okay? 2 and 12, is that going to work? Can I do minus 2 plus 12 plus 2 minus 12? Those aren't going to work, right? Hopefully you can see why that's not going to work as well. So we can kind of just think of the factors themselves and think about combining them in ways, but you just got to be really careful with the signs. So what else? 3, 8, 16, 24, 3 and 8. Is that going to work? Let's see, minus 3 plus 8 plus 3 minus 8. That's not going to work. 6 and 4 I think is going to do it, right? And we can kind of see, oh, those are 2 away from each other, so that makes sense. I need positive 6 and negative 4. Those add together to be 2 and multiply together to be negative 24. So again, as you gain experience, you don't need to list all this stuff out. You're probably just going to pretty quickly jump to the answer. And that's totally fine. That's awesome. That's what's supposed to happen. So let's see what we can do here. We can rewrite this as 8x squared. And we have this plus 6 minus 4. Those are our magic numbers. So I'm going to do plus 6x minus 4x minus 3. All right, let's see how this works out. Greatest common factor between the first two terms is, I believe, a 2 and an x. Let me double check that. 4x plus 3. And how you can check if it's the greatest common factor is if you factor it out, there should be no other common factors in here, right? So we're good. So let's think about what we're going to do here, because remember, we sort of need to anticipate. We need to think ahead about what we want to end up with, which is another 4x plus 3 in parentheses. How could we get that? Well, we could get that by factoring out a negative 1 is one way to think about, right? But really we're writing minus and then writing everything in parentheses, because when we distribute this negative, we get exactly back to where we started. So these two things are in fact equal. And again, I think it's really helpful that once we get our first parentheses, we're kind of thinking about, okay, how do we force that to happen here as well, right? So again, the next step is 4x plus 3 is going to come out in front. And what are we left with? Well, 2x, and then again, a little invisible -1 there is how I like to think about it, right? 4x plus 3 times 2x minus 1. Hopefully you're getting the hang of this. This is making sense. Pause the video and try this one of your own at this point if you're feeling good about it. Here we have a minus minus. I think this is the first example we've had like this. So let's see, what is AC? It is again a negative. Oh, but I don't think the minus minus really makes too big of a deal, right? It's a similar situation what we had last time where one's going to be positive, one's going to be negative, but this time we want them to add together to be a negative number, right? So that means we want the negative number to be further from 0 than the positive number, right? So 24 and 1 definitely won't work. What about 2 and 12? I don't think those are going to work. 8 and 3, I think 8 and 3 are what's going to work. So let's think about which one's negative, which one's positive. Minus 8 plus 3, yep, that's going to work. And hopefully that's making sense how I'm thinking about it. We're taking the numbers, we're subtracting them in our head, and we're thinking about, do they give us like either positive 5 or negative 5, right? Can we make it equal to negative 5? Because if we switch these around, then we get positive 5. And so the number, like the absolute value, is always going to line up. We just need to make sure we're really careful about our sign. So minus 8 plus 3 together gives us minus 5. And so this is equal to 12x squared. I'm just going to write it out as minus 8x plus 3x minus 2. Okay, so let's see, what's my next step? And this is going to be one of those weird ones where I'm already looking ahead at my last two terms and seeing that they don't share a common factor. And so I'm already thinking ahead about that, right? So let's see, what can I take out here? A 4 and an x. What do I have left? 3x minus 2. And in this case, it's not too bad because that's exactly what I have here. So I don't need to do any weird like changing signs, factoring out a negative business, right? I can just think of there being a little invisible 1 there. Now I can think about bringing out the 3x minus 2 in front. What am I left with? 4x plus 1. And we are good to go. Let's see, do we have one more example? I think this is the last one. Last example. All right, let's finish strong. So a times c, 10 times negative 6, that is negative 60. Numbers that multiply together to be negative 60 and add together to be positive 11. Okay, 60 and 1 definitely not going to work. Hopefully you can see why, right? Whether it's minus 1 plus 60 plus 1 minus 60, 2 and 30 aren't going to work. We kind of want numbers that are close together. In fact, I think we want them to be a distance of 11 from each other. Ooh, that looks like they're a distance from 11 from each other. So why do I say that? Well, because in either case, whether we have minus 4 plus 15, that gives us positive 11, or plus 4 minus 15, that gives us negative 11, right? So this number always kind of tells us the distance between the two numbers when they are both positive, when we just consider the numbers without any signs, right? That's one way to think about it. All right, so what are we going to do here again? Okay, plus 15 minus 4. That should work. Awesome. All right, so we can rewrite this. 10x squared. Yeah, everyone has a different way of thinking about how to do this process. Sometimes I have students who actually share really insightful ways that I had never even thought about. So however you think about that is fine, as long as you're able to get that minus 4 plus 15. All right, what are we taking out here? 5x. And what are we left with? 2x plus 3. Okay, and then what can we take out here? So here's where it gets a little weird, right? Because there is a common factor of 2. But the problem is that if I write plus 2, what am I left with? Minus 2x minus 3. And I don't want that because now the stuff in my parentheses isn't the same. So I actually don't have a common factor now, right? So I really want to take out a negative 2. That's how I think about it. We are factoring out negative 2. And what we have left is 2x plus 3. And you can verify that this is correct. Distribute the negative back in. You get minus 4x minus 6, exactly where we started, right? So that 2x plus 3 comes out in front. We factor that out in front. And what we have left when we take that out of both terms is 5x minus 2. All right, so this is the AC method. Again, it's a method that always works. It works really well if you like it. There's also the trial and error method. It's really about whatever you want to do. So hopefully this video helped. Ask any questions in the comments. I'll try to get back to them. Like the video, subscribe, do all that stuff. But most importantly, keep flexing those brain muscles. And I'll see y'all later.